Hello, welcome. This is a video on how to solve equations using square roots, quadratic equations using square roots. We can only do that. Remember that if we've got ax squared plus bx plus c equals 0, you can only do this if there's no x term. If it's just a squared term and a constant, then you can solve using square roots. And the key there is to make sure that your squared term is alone. In this example that we're given, it is. We've got x squared alone. And so we're ready for the next step. So we just say x squared equals, and I like to leave some space here, a little space, and then put, let's say the square root of 100, sorry, not square root yet, equals 180, because the opposite of squaring something is taking the square root. So to undo this square, we're going to do the square root, and then over here the square root, and we need to add this plus or minus, and that's why we wanted to leave some space there. So the square root of x squared just leaves us with x, and then basically this is our solution, but we want to simplify it. We have in the perfect squares, let's say from 100, I've got a square root of 100, I've got a square root of 121, the square root of 144, the square root of 169, and the square root of 196. See, this is 10, and this is 11, 12, 13, and 14. And so the square root of 180 is an irrational number. It's going to fall right in there between 13 and 14. It's going to be 13 point something. And while it's a decimal, non-repeating, non-terminating decimal, we can still simplify it. And so there's a couple ways that we could think about this. But this maybe is the most straightforward, kind of easy way. I don't know if that's true, but here's one way to do it. I'm going to start with the prime numbers. The primes, you recall, I'll put them down here. The primes are 2, 3, 5, 7, 11, 13, 17, 19, and then, it continues, but that should be plenty. So I just say, well, will 2 go into, I start with the smallest one and ask if it's a factor. And since 180 is even, I know that it is. So I say 2 goes into 180 90 times. And then will 2 still go into 90? Yes, goes in there 45 times. Now 45 is no longer even, so I ask myself, can I divide it by 3? And there's a quick test, short of just putting it in your calculator, if you add the digits. While 4 plus 5 equals 9, since 9 is divisible by 3, so will 45 be divisible by 3. So I divide that by 3, and it goes in there 15 times. Once again, 3 goes into 15 5 times, and then 5 goes into another prime number goes into itself 1 time, and when you get to 1, you're done. So I can rewrite then, these are my prime factors, and so I can rewrite the square root of 180 as 2 times 2 times 3 times 3 times 5. And this pair of 2's is going to come out as a 2. This pair of 3's is going to come out as a 3. And where this 5 does not have a pair, it's going to stay under there as the square root of 5. So we still have the plus or minus there out in front. We don't want to leave it like this. We want to simplify it down. 2 times 3 would be then 6. We've got 6 square root of 5, and we have the positive value and a negative value, and those are my values of x.